Chapter topic something, I don't know what was it. This one, yeah. Chemical analysis, topic 11. It's the same as chapter 2. So we should go through this a bit quicker. Why did that open? Yeah, we should go through this a bit quicker. Okay, what happens when you add NH3 to a copper solution? Okay, أول شيء copper will get you a pale blue precipitate. Okay, that's it. That's pretty much it. We know copper is blue. ما بدها الأد. Question 2. When HCl is added to potassium carbonate KCO, K2CO3, the resulting mixture effervesces. مهم, it bubbles. Effervesces يعني bubbles. Okay, what are the properties of the gas? Okay, when you add an acid to a carbonate, we know it forms CO2 gas, وكمان it forms water, right? طب هنا what they're saying properties of the gas. The gas is colorless because it's carbon dioxide, and it's an odorless gas because carbon dioxide does not have any odor. Is it yellow green? No. It if they put it turns lime water milky white or cloudy white, whatever, that would be correct as well. What's the formula? Kid CO2. The gas that okay, they said it here, turns a clear lime water milky. 3. Okay, you add NH3 to zinc or Al. Which of the following is observed when you add NH3 to zinc and Al? You get a white precipitate. Remember, CaAlZn, NaOH, NH3, right? On insoluble, no reaction. Soluble, insoluble. Soluble, soluble, right? If you add NH3, and they said also Ca2 plus, you would say a white precipitate would form except for the tube containing calcium, because you know calcium has no reaction with NH3, right? Okay, but with zinc and aluminium, they have reactions, but forget about the solubility. They're talking about the precipitate, whether it forms or not. Okay, an excess of ammonia is added to the mixture and the precipitate dissolves. Which one has the one that where ammonia dissolves? Zinc, Zn2 plus. You have to include the charge, obviously, okay? Always include the charge. The charge is given in the question, it shouldn't be hard. To identify silver ions, silver is Ag. Now, what does Ag react with? Remember, Ag reacts with the Cl, Br, and I. Cl, Br, I. Any compound containing them. So these are obviously wrong. Which one can be identified? It's used to identify ammonium. Ammonium is NH4. Remember, to get to NH4, it will react with sodium hydroxide, NaOH, to produce ammonia. Okay, so addition of ammonia and then followed by litmus paper test. This litmus paper test is basically the addition of sodium hydroxide followed by litmus paper test. The litmus paper test is used to test if ammonia was formed, because if you check the litmus paper test and it turns blue, that means ammonia was formed, because ammonia is a base and bases turn litmus paper blue. 5. Okay, if you add NaOH, okay, sorry. Sleepy. Okay, they added NaOH to a solution of calcium chloride. Okay, what happens? Obviously, you're gonna get a white precipitate. Why? Because for calcium, we said, remember calzone. Calzone. You know, NaOH, and here you have NH3. Right, we said if you add NaOH to calcium, you're going to get a precipitate, but that precipitate is insoluble in excess NaOH. So you're going to get a white precipitate if you add NaOH to calcium. Remember, you're going to get a white precipitate for any of these three, okay, except for when you add ammonia to calcium, because ammonia with calcium has no reaction. Write the net ionic equation of the expected reaction. Okay, net ionic can include only the predominant ions and the precipitate. Now, what's our precipitate? We're getting a white precipitate. Akid, that is, listen, calcium, always the first one mixes with the last one, right? So you're going to get CaOH as your product, right? But how do we know the formula of CaOH? You have to check the charges. Obviously, it's Ca2 plus, and OH is always minus. Walid, how do you know it's 2 plus for Ca? It takes the charge of the second subscript, right? And at this point, you guys should memorize the charges. And check the periodic tables. Calcium is also in group 2. Anyway, this, you crisscross, you're going to get CaOH2. So we want to write the reaction for it. You draw an arrow. What makes up CaOH2? Obviously, we have calcium and OH, right? طب ماشي, they're obviously aqueous and a كلهم aqueous except the precipitate, because obviously the precipitate is solid, it's a solid precipitate. So عندك aqueous solid, ions are always aqueous. بعدين you just fill in the charges وcheck is it balanced. أكيد no, you have to put a 2 here for the OH. Okay, that's it. 6. Okay, oh my god. طيب, this table below summarizes, okay, I will see what we're talking about solution A. Let's ignore B. So this solution A, when you add sodium hydroxide to NaOH, you can get a white precipitate that is soluble in excess NaOH. Okay, so yani, when we're talking about excess, yani, we're talking about our calzone, right? NaOH وهون NH3 insoluble, soluble, insoluble, soluble, soluble. Okay, قلنا انه it's soluble in excess NaOH, يعني أكيد it's not Ca, right? It's not Ca because Ca is insoluble. Then what did they say? They said when they added to NH3, it's insoluble in NH3. So which one's gonna be? It's gonna be Al, right? So it's gonna be aluminum. ماشي. Write a net ionic equation expected for the reaction between the cation in solution A, okay, so Al3 plus, and NaOH. We know we're mixing Al3 plus with NaOH. أكيد, like we said, it's gonna mix with the anion. You know, the anion is always the second one. So OH minus. We crisscross, right? AlOH3, right? That's our product. How do we form it? Al3 plus OH minus. أكيد aqueous solid because it's a precipitate. طيب عندك 3 هون, so you have to put a 3 here, right? It's balanced. ماشي. Which cation is present هلا in B? Let's see B now. B, when they added sodium hydroxide, NaOH, it was soluble. So come on, we can go back to this table here. So it's one of these two. Then when they added ammonia, it was also soluble. So meaning it's zinc, right? Zn2 plus. Then they said write the net ionic, same thing. Okay, let's see what's the product we get. We have Zn2 plus and OH minus, right? Crisscross ZnOH 2. Let's see, how do you get that? You get Zn, you get OH minus, Zn2 plus OH minus. طيب, you have aqueous, solid, right? طب ماشي, let's balance. You have OH2, so you can put 2 OH. That's it. Okay, NaOH is mixed with NH4Cl. NH4Cl is ammonium chloride. Okay, the resulting solution is warmed and the gas evolves. أكيد, what's the evolved gas? And when you mix ammonium NH4 with sodium hydroxide, you get NH3. Okay, obviously it's ammonia. What's true about the gas? أكيد, pungent smell, blue litmus paper. Does it turn like water milky? No, that's for carbon dioxide. Does it relight a glowing splint? No, that's for oxygen. And does it turn the flame lilac? أكيد, that's for potassium. 8. Okay. We have 3 ions, Br minus, Fe2 plus, and K plus, and they're mixed together and separated by precipitation. Using S1 and S2 solutions, the precipitation reactions are followed by filtration. Okay, let's see here. So we had these. We added some drops of S1. We got a solution and we got a creamy precipitate. Immediately, the only thing that gets you a creamy precipitate means you added Ag, right, to Br, right? What do you add to Br to get a creamy precipitate? Ag, right? ماشي. They filtered it, so يعني they took out the creamy precipitate. يعني خلصنا من ال AgBr. So هلا we're just left with Fe2 plus and K plus. Okay. When they did it, they got sorry. I shouldn't. They filtered it and they got the creamy precipitate AgBr on the side. خلاص طلعوها, and we got the solution. Then in the solution, what did they do? They added drops of S2. When they added that, they got a green precipitate and a solution. Which one here gets you green precipitate? أكيد Fe2 plus, right? So this is Fe2 plus. What do you add to Fe2 plus to get a green precipitate? NaOH or NH3. Okay, NaOH. لا تدور. Okay, and then they filtered out the green precipitate to get the solution on the side. Okay, the formula of S1. What did we add to Br? How do you get a cream precipitate? You have to add Ag, and you don't just add Ag, you have to add acidified Ag, so it's AgNO3. Okay, what's the formula of the cream precipitate? We know it's AgBr, and so we already answered these questions. What's the formula of S2? NaOH. If they put NH3, I'm pretty sure that's correct as well, because over here Fe2 plus. Yeah, it dissolves also if you had NH3. But in this case, they didn't put NH3 in the choices. So if they put it, you choose it. But they didn't. Okay. Give the formula of the green precipitate that forms. It's Fe. We said it's iron, right? Iron with NaOH. So what does it react with? It reacts with OH minus group, right? So Fe akid 2 plus OH minus. You're going to get FeOH 2. Okay, 9. Which of the following can be used to test for sulfate ions? Sulfate ions, you add barium, always barium, and acid has to be acidified, so barium nitrate. Write the expected net ionic equation. Net ionic, yani you just care about the ions that make it up. When you react BaNO3 to barium nitrate with SO4, you're gonna get BaSO4. Memorize it. Okay, this is a solid. Okay, how do you get BaSO4? You have Ba2 plus SO4 2 minus. Okay. How do you know the charge of Ba is 2? Look at the subscript of NO3. So you just take it up. Okay, أكيد هولي aqueous aqueous it's already balanced خلاص. What's the color of the precipitate? BaSO4 is white. Okay, a few drops of sodium sulfide Na2S are added to lead nitrate PbNO3. Which of the following is observed? Okay, so apparently, obviously, when sodium mixes with the NO3, there will be no precipitate. But when you mix sulfur with lead, and I think it was in the notes somewhere, and no, sulfur doesn't dissolve with lead. Yeah. So it will form a precipitate, sulfur and lead. Okay, so you're gonna get PbS. طب وليد, طب do the charges. Let's see. Obviously, the charge of Pb will be 2 plus, right? Because the subscript of NO3 is 2. The subscript takes the charge. وهون the charge of sulfur is also 2. Because Na takes the charge of S. Okay, and they cancel. That's why you get PbS. أكيد solid. So this is your precipitate, lead sulfate, and you have to memorize that it's a black precipitate. What's the net ionic equation? You write down أول شي your product وبتكتب Pb 2 plus أكيد aqueous وsulfur 2 minus كمان aqueous, and you get the full mark. It's already balanced, no? Test 11, true test 11. Question 11. Okay, what turns a damp litmus paper from red to blue? Ammonia. Very fast. Memorize this. Bleach. Anytime you see bleach, chlorine. Okay, أنا حافظة. Okay, why? Because chlorine, they use it in making bleach and Clorox and stuff. Most people, they know the cleaning product called Clorox. I don't know how you pronounce it, but it's made out of bleach, which is chlorine. In Arabic, we call it chlor. That's why I remember it. Gives a pop sound. Okay, hydrogen, right? Hydrogen, always memorize. Turns lime water. Anytime you see lime water, carbon dioxide. Turbid and white. Turbid, yani creamy. Okay. Question 12. Again, match each gas to its property. Oxygen, it lights a splint, always. Chlorine bleaches, always. NH3 turns moist. It has to be moist, huh? Litmus paper blue. أكيد يعني كمان if they don't say it, يعني it doesn't, I don't think it matters. But whenever you see moist or damp, think NH3. 3 gases are introduced in a container. A moist litmus paper is bleached when inserted into the flask. Bleached. Cl2. بسرعة. Which of the following are properties of Cl2? It produces a pop. No, that's for hydrogen. It turns lime water milky. That's carbon dioxide. It relights a glowing splint or rekindles. That's oxygen. It's yellow-green gas. Yes. How you have it memorized? Chlorine, yellow-green. They rhyme. Okay. It is a choking gas. Yes, chlorine is choking. Although it was never mentioned, chlorine chokes you. It's not good. I think, if I'm not wrong, in World War II, they would... I don't know if it was tear gas or chlorine gas, but Hitler in the concentration camps, the Jewish concentration camps in Auschwitz, he would trap them in a gas chamber and release chlorine gas, which would choke them and kill them. This isn't a history lesson, but just whatever helps you understand, I guess. 14. three gases again. A glowing splint is reignited يعني أكيد oxygen. Yeah, خلاص, you should have them memorized by heart. What are properties of oxygen? It's colorless أكيد, it's odorless. Oxygen is just a chill gas. There's nothing like it doesn't really have anything. It turns lime water milky, no. Acidic, no. It's yellow green, no. It's just chill يعني. ما في شيء. It doesn't do anything other than relight a splint. HCl reacts with metals such as magnesium or zinc to produce a colorless and odorless gas A. When a slit splint is inserted into a test tube containing gas A pop is heard. Give the formula of A. Whenever you see pop, hydrogen. But don't put H, it has to be H2 because hydrogen, you guys know, is diatomic. Hydrogen makes a pop. Done. SO2 decolorizes potassium manganate because SO2 is a reducing agent, right? Cl2 bleaches. Easy. NH3 litmus paper makes it blue. Easy. Carbon dioxide turns lime water milky. Easy. Oxygen 3 lights a glowing splint. خلاص. Easy. بكفي. يعطيك العافية. Okay. Question 17. A student performs the tests on X and Y. He adds a few drops of NaOH to each of the two solutions. Okay, in X he gets green. In Y he gets white. Okay, I think obviously there are more than one correct answer, but I think it's depending on the choices. So I'm gonna explain why this is correct. Okay, I can't see the choices, but obviously green precipitate means either Fe2 plus and Cr3 plus. One of them, but I don't think they put Cr3 plus. That's why okay, there's no Cr3 plus. You choose Fe2 plus. How about this one here? When you add NaOH to zinc, you get a white precipitate. Not only zinc, remember cal, zone. Any of these three, you would get a white precipitate. Okay. 18. 2 drops of ammonia or NH3 are added to test tubes X and Y. A white precipitate forms in both tubes. Okay. When an excess ammonia is added, the precipitate in X dissolves, while in Y it doesn't. What is the only one that dissolves in excess NH3? It's zinc. I'm tired of writing this table all the time. Calzone. And I'll just write insoluble, no reaction, soluble, insoluble, soluble, soluble, NaOH, NH3. Okay. Choose the formula of X. أكيد the one that dissolved in excess NH3 is zinc 2 plus, Halide 3 plus, Halide 2 plus. Okay, why got you? See, here's the thing. Some people will be confused. شو خلص, why isn't it calcium? In calcium, when you add NH3, there's no precipitate formed. But in Y, it got a precipitate. So أكيد it's not going to be calcium. It's either going to be aluminum or zinc. And since they said it didn't dissolve in Y, it's aluminum. Because aluminum doesn't dissolve in excess NH3. 19. 2 solutions that contain unknown solutions A and B respectively are subject to a flame test. A was lilac يعني K plus potassium. B was brick red. Brick red يعني calcium. That's it. Okay, question 20. Okay, HNO3 يعني nitrate reacts with CaCO3 and the gas evolves. Okay, yeah. In this case here, you have nitrate ions and you have CO3. Okay, some people will be confused as to which one you're testing for in this case. Remember, this here is nitric acid. NO3, to test for NO3, you add an acid. Okay, or wait, no, do you? You don't. Sorry, not acid. You add a base, cause yeah, you add a base. For NO3, you add a base. In this case, we ain't adding a base, so that means we're not testing for NO3. طب how about? And what else? And what else could I be testing here? CO3, right? CO3, CO3 plus acid, in other words, H plus. Okay, gets you CO2 gas plus H2O liquid, right? ماشي. In this case, where are you getting the acid from? HNO3 is nitric acid. Okay, خلاص, memorize it. So أكيد the gas that evolves is carbon dioxide. Okay. No, you see CO3 reacting with an acid, yani it's going through this reaction, produces carbon dioxide. From the name, CO3, carbon dioxide, carbon, CO, you know. Write the net ionic equation. Okay, very easy. For the expected reaction, do not forget to include statements. Okay. Net ionic. Net ionic means, I don't think this is correct. Net ionic is usually when you have a precipitate, no? Anyway, I think they just mean to write the whole reaction, and we already wrote it. CO3 2 minus plus H plus to produce CO2 gas plus شو اسمه I forgot what it's called. Yeah, H2O water liquid. ماشي balance. You're gonna put a 2 here. That's it. أكيد the state symbols هولي دايما aqueous. هيدي أكيد gas هيدي liquid. Okay. How do you test for this gas? Obviously CO2. You have to see if it turns lime water milky. Is this quiz 37 questions? Oh my god. Okay, if the solution contains okay, if something contains a lot of H plus, it means it's an acid. Okay, and if something's an acid, that means the pH. Yeah, this is common knowledge. It's less than 7. Okay, this is I think maybe my brother Adam knows this. He's in grade 6. Okay, drag and drop what color each compound gives in a flame test. Okay, lithium أكيد crimson red, potassium K lilac or violet, Na sodium will be yellow. These are the easy flame tests. أكيد guys كله حفظ chemistry كله حفظ for now يعني. A flame test is conducted on a sample of calcium chloride. So we're flame test and we're testing in this case what will the flame test detect? It detect calcium, and for calcium what will it be? Brick red, not normal crimson red, no, brick red. So it's kind of like more orangey. You know what I mean? When HCl is added to magnesium ribbon, Mg, a gas evolves, right? Sorry. When it's added to Mg, a gas evolves. Okay. Basically, what's happening here? Okay, you have HCl plus Mg2 plus. What happens is this Mg2 plus, it steals this Cl and becomes MgCl2. Okay, and this hydrogen just stays alone. Okay, do you get what I'm trying to say? Even though this wasn't like covered in the notes, this specific reaction, but I'll still explain it. Yani. Okay, so in that's not the actual reaction now, but I'm just kind of explaining what's happening. So the gas that gets released in this case is hydrogen, because the Cl goes with the Mg, the hydrogen gets released as a gas. What's the net ionic? طيب ماشي. نحن we got what's this? Oh, okay, my fault. Listen, what actually happens? You guys know HCl dissociates into H plus, okay, and Cl minus. Forget the state symbols. Okay, so you have this HCl, in other words, is H plus and Cl minus, okay? So what happens is this H plus reacts with this, like over here, reacts with the magnesium to form magnesium ions, yeah, Mg, as an ion now, and hydrogen gas. Just memorize. Wallah, just memorize. Okay, it's something specific you have to memorize شكله. I think جابوها من البوك because it wasn't in the notes. بس خلص احفظوها. You're gonna get hydrogen plus magnesium, normal magnesium solid, right, as it was here, to produce magnesium ions plus hydrogen gas. Which of the following is true about the gas evolved? In this case, it's hydrogen. It makes a pop sound, right? Question 25. Okay, I did this in the other quiz. Okay, chemical formula of the precipitate form. Let's see. In this case, you're reacting Fe with sodium hydroxide, NaOH. We know when you do that, you're gonna get FeOH3 because the Fe will react with OH group, right? If you crisscross the 3, because it's Fe 3 plus OH minus, the 3 goes down, you're gonna get FeOH3. Okay, and you know, for Fe3, the precipitate is red brown, or some people just say brown, right? Reddish brown. Oh, you have to say red brown. Okay, you have to say red brown. You can't just say brown. Okay, here for copper, نفس الشيء, the copper is going to react with the OH, so it's going to take the 2 down to OH, it's going to become COH2. You know, since copper, you say light blue or pale blue or just blue. Okay, for copper, you can just say blue, but for this here, you have to say red brown. Okay, and here, again, Fe reacts with OH, you'll get, take the 2 down, FeOH2. Since it's 2 plus now, we can just say green. Some people say dirty green, right? Yeah. You can say whatever, yani. Okay, a few drops of an acidified barium chloride solution, BaCl. Okay, 2. are added to a solution that contains potassium and SO4 minus, right? The net ionic that happens. Okay, we know that the barium, if you add acidified barium to SO4, you get a white precipitate. So we're gonna get BaSO4 as my precipitate, right? So they're saying write the net ionic. How do you get BaSO4? You get Ba plus SO4 to produce BaSO4. Let's put the charges. Okay, 2 plus, 2 minus. Group 2. This is group 2. SO4 2 minus is given. Okay, ions are aqueous. Aqueous. Okay, the BaSO4 was solid. Very easy. Which of the following is observed on BaCl2? BaCl2 is a white precipitate. Question 27. Three chemicals X, Y, and Z are to be identified. The tests are conducted using AgNO3 solution. The results are given in the table before. Okay, if it's creamy, Br. Yellow, iodine. White, chlorine. Right? Okay, in order to identify two unknown chemicals X and Y, a student performs the test described in the table below. So in X, he added some HCl, and what happened is you got a colorless gas that turns lime water milky. This gave it away, and we know that the gas is CO2. To get CO2, yani what are we testing for? Carbonate, right? CO3 2 months. Hello, why? For I don't know what this here is. For Y, he added a few drops of barium chloride and he got a white precipitate. When you're adding barium, maneta, you're testing for sulfate. Always. Sulfate, sulfite. Two different things. I got it wrong at AMS because I mixed up between sulfate and sulfite. Okay, don't make the same mistake I made. Sulfite is SO3 2 minus, sulfate is SO4 2 minus. Okay, Selena added a few drops of NaOH to an unknown chemical X and warmed the mixture. Okay, after she warmed it, a pungent smell gas that turns a moist red litmus paper blue is formed. Okay, what is the formula of the ion tested? Listen, we got a pungent smell. Pungent smell يعني NH3. Okay, ammonia. من الآخر. To get ammonia, you either have NH4 or NO3 minus. What's the difference? This one you just add NaOH. Okay. This one here you add NaOH and aluminium. Did they say anything about aluminium? No. So you choose NH4. Okay, that's why this is X. He then added some AgNO3 and she got creamy. يعني أكيد Br minus. What's the formula of X? You have NH4, you have Br. Boom. 30. A few drops of NaOH, and now they said aluminium. Anytime you see aluminium, and then they said a pungent smell, yani ammonia, right? Yani they're giving it away, NO3 minus. A clean platinum wire is first dipped in HCl solution and then in Y. The wire is then placed on a flame, and the flame turns yellow. Akid, sodium, right? Give the chemical formula of Y. You have NO3, you have Na, so just NaNO3. Very, very easy. Always the positive one before the negative one, yeah? 31. I hope the questions are short like this. Okay, again HCl. Okay, it effervesces, making a colorless gas that turns lime water milky, and the gas is carbon dioxide, right? And what are we testing here? CO3 2 minus. Only carbonate ions produce carbon dioxide. Okay, then they did wire dipped in HCl, Bunsen burner flame. The flame turns lilac, like yani potassium K plus. So write the formula. Akid, you have to crisscross, yeah? So the 2 goes here to the K, and the 1 goes to this. It doesn't matter. So you're gonna get K2CO3. Okay. 32. Okay, NaOH is added, you get red brown precipitate. AgNO3 is added, you get a yellow precipitate. Okay, whenever you get red brown, yani Fe3 plus. When you get yellow precipitate, yani I minus. So Fe3I. Sorry, no, sure. It's Fe3 plus and you have I minus, right? We want to see what's the product. Crisscross, you get FeI3. 33. Okay, the test, they added some sodium hydroxide and NaOH and some aluminum powder, and then they warmed, they got a pungent smell gas and NH3. Okay, and it turns litmus paper blue. So they're basically giving it away, and it's so easy. When you add aluminum, which was the only one that adds aluminum, NO3 minus. Again, the way I memorize it is because NH4 is very close to NH3, so there's no need to add aluminum, right? But NO3 is kind of like its chemical formula is a bit far from NH3. That's why you have to add aluminum. That's how I memorized it, So so our first one is NO3 because they add the aluminum. The second one, they dipped it in a wire flame test, and they said the flame turned yellow. Yani it's Na, right? So you have Na plus NO3 minus. What's the formula of Y? Okay, this is the one whole solution, huh? NaNO3. Okay. 34, okay. Okay, when you have many OH minus is the thing for base. If there's a lot of OH minus, yani, it's greater than 7 because you know bases are greater than 7. Again, well, I think Adam, yani, if you ask him this, he probably could get this correct. This is like grade 7, grade 6 stuff. A silver nitrate solution, AgNO3, can be used to test for halides. Okay, what would happen if you mixed each one with AgNO3? Cl, white. Br, cream. I, yellow. Very easy. Write the net ionic for each one. Okay. We'll be quick with it. خلاص, we'll be fast. Okay. We know that our precipitate for NaCl, this one will be AgCl. This one will be AgBr. And this one will be AgI. So for AgCl, أكيد it's a solid precipitate. You're adding Ag plus UCl minus, right? Aqueous. خلاص, very easy, memorize. هون نفس الشيء, Ag plus, write fast, وBr minus, aqueous. Okay, هون AgI, again, Ag plus, I minus, aqueous. Ag plus is very famous, everybody should know it. And then the 7, the Cl, Br, and I, they're always minus. They're in group 7, so okay, they're going to be minus. 36, H plus with HCO3 and CO3 minus produces a gas. Okay, so you're basically adding an acid. When you say H plus, you're adding an acid. Write the equation of the reaction between HCO3 and H plus. Okay. We're reacting pretty much the CO3 with the hydrogen, right? So, like, you're reacting it with H plus. H plus means acid. Whenever you add an acid to anything that has CO3, you get carbon dioxide gas and water, right? So as usual, we know our product. Sorry, I'll erase this. We know our product is carbon dioxide gas, right? Always. Or I won't start the products. I'll start easy. خلاص, we start HCO3 minus أكيد aqueous plus. Okay, what's the other one? H plus, right? H plus, which is also aqueous. When you're adding any carbonate with any acid, you're gonna get CO2 gas, carbon dioxide يعني, H2O liquid. Yeah, that's pretty much it. Yeah. Okay, then this one, same exact thing, but instead of H, it's just CO3 2 minus. وكمان you have to balance it here. Here it's already balanced. Here you have to balance. Please don't forget to balance. Okay, even they're telling you balance. يعني حرام. Okay. Why is this the same? Because in اثنيناتهم CO3, huh? But home, what's the difference? They have the H, that's why it becomes minus. This one doesn't have H, so it becomes 2 minus. And command the balancing part. How can the gas be identified? How can CO2 be identified? It turns lime water milky. 37. Okay, when a solution containing SO3 is warmed in a HCl solution, you're adding sulfite to an acid. What do you get? SO2. The reaction for this is SO3 2 minus, aqueous أكيد, plus any hydrogen, any acid represented by H plus, it's 2H plus, because you're gonna I'm just balancing it from now. You're gonna get SO2 gas plus H2O liquid. Extremely similar to the one for CO3 2 minus. It's the same exact thing, except instead of S, you have C. There's the same reaction. ونفس الشيء هون, if you get CO2, isn't that just the same as SO2, which just changes the S with C? Yes. Okay, so okay, the gas evolved as SO2. What is true about... this is wrong. Definitely wrong. It doesn't have a pungent smell. It has a choking smell. Let me make sure of this though. Okay, never mind. I checked it. Apparently this is correct as well. Sulfur dioxide has a choking smell. That's what I know. Apparently choking smell is the same as pungent smell. Okay, it turns a wet litmus paper red, أكيد, because sulfur dioxide is acidic. It bleaches, no. It decolorizes potassium manganate, yes, because we said it's a reducing agent. It relights a glowing sprint, أكيد. I think we're done here. Thank you so much for watching. Good luck.